Starting from this lecture, we will be covering a few sorting algorithms. The first one, insertion sort algorithm. Before we look at the sorting algorithm, how to design it, let's look at the standard sorting method in Java API, arrays.sort. The arrays.sort method. Sorting is a frequently used algorithm in programming. Java provides several overloaded sort methods for sorting an array of integer, double, character, short, long, and float in the java.util.arrays class. Basically, it covers all of the primitive data type. And if you have any object type that implement the comparable class, it can also sort them. For example, the following code sort an array of numbers and an array of characters. So you prepare the array of doubles or an array of characters. You can use the sort algorithm like this. It will help you to sort it out by an ascending order. If AP tests want you to write a sorting program, do not use this because they want you to design a sort algorithm, but don't want you to code it directly. But if the problem is not on the sorting algorithm development itself, you should be able to use it and must use it correctly. Array class, java.util.arrays class sorting. The java.util arrays class contains various static methods for sorting and searching arrays and comparing arrays, filling array elements, and returning a string representation of the arrays. These methods are overloaded for all primitive data type. Remember, all primitive data type can also use it. So you can do sort, parallel sort. It's different algorithm, but do the same sorting. And you can do sorting and parallel sort for character as well. Let's look at insertion sort now. Insertion sort. The sorting method for insertion sort is, initially the sorted sublist contains only the first element, and then you try to add the second element into the sorted part. So if this one is smaller than 2, you put in front of 2. Otherwise, you will put behind it. And then we find the next element, trying to put it into sorting order. So right here, you need to put the 5 between 2 and 9. So we need to insert here. In order to insert 5 over here, you need to shift 9 to the location of 5, something like that. And the next one, we would like to insert 4. So we need to also insert it here. So we need to shift 9 to 4 location, 5 to 9 location, and then put 4 into 5's location. Similarly for 8. You need to move 9 to 8's location and put the 8 back to this 9's location. So as you can see, here form a certain type of the shifting in circular format. So you shift to the right, and then the last element need to put into the first element location. And this location is the location that you would like to insert it there. And how to find out the insertion location for the next element? Basically, you need to find the location that start to be greater than this element. Now let's look at how this works. If this array is unsorted, then the first step, we try to put the 2 into the sorted part, and then we start to compare 9, and 9 is bigger than 2, so we put 9 after 2. And then the next one, we try to compare 5, and starting from 2, 2 is less than 5, so we compare 5 with 9. 9 is bigger than 5, so we need to insert 5 over here. So we shift 9 over 5 location and put 5 over here. Something like that. And then we try to use 4. 4 need to insert here. Shift it, and then put 4 here. And then we try 8. Need to shift it and put 8 here. And then try 1. 1 need to be put it here. So shift 9, 8, 5, 4, 2. And then put 1 here. And same thing for 6. You need to put here, shift, and put here. And then it's sorted. Now, let's look at our AP Computer Science A Part 1, the Chapter 7, Array Processing 1. We have this shifting element method. Basically, we want to do the right shifting, so we need to start it from here. If this one is the one you want to do insertion, you need to put it into a temporary storage. And then we start to shift the one next to it, that is the mylist.length minus 2, and then shift to the right. This one is shift to right, and continue to do that until the last one, the temp value need to put into this 0 location. So 0 is the starting location, and mylength minus 2 is this location. Mylist.length minus 1 is for temp value. So remember, we need to store this one into the temporary location and then start to shift from here. And then the last one, we put this back to the head. So that's the way we would like to sort it. And this shows you the 4 steps how to do insertion. Now let's look at the idea to solution. So first, we need to pick the second element, starting to compare it with the sorted part. So insert this I into a sorted sublist from 0 to I minus 1. That's the list sorted. And then we start to do shifting. And there it is done. So now we expand this part into this. We start from the I minus 1, and then while k is greater or equal to 0, if this k value is greater than current element, then we keep shifting until the 1 is less than the current element. We stop shifting. At the end, we need to put the current element back to the k plus 1. Why k plus 1? Because here we keep updating until maybe k is less than the starting location of I minus 1. So we need to put the 1 back to there. Analyze insertion sort. The insertion sort algorithm presented in InsertionSort.java sort a list of values by repeatedly inserting a new element into a sorted partial array until the whole array is sorted. So for case iteration, you insert an element to an array of k and may take k comparisons to find the insertion position. K moves to insert the element, and that's T of n denote the complexity. T is time complexity for insertion sort, and the C denoted for the total of other operations such as assignments and additional comparison in each iteration. So C is a constant that you need to do for each loop iteration. And for case iteration, you pretty much need to do 2k operation. K comparison to find the insertion position, and K move to insert the element. So totally you need to do 2k. So here is 2 times 1, 2 times 2, 2 times n minus 1, and each one with a C constant time. And totally the equation for time complexity is n squared minus n plus Cn. So this we call it, in big O notation, is n squared algorithm. And n squared algorithm is considered to be expensive. It will grow quadratically. Now let's look at the BlueJ program. We have one sorting package. Go into there, we have insertion sort. Let's open it. So for the algorithm part, we have explained it. So basically, you try to start from the second element, that's I equals 1, to the end of the element. Each time we try to insert this element back to the sorted list, and the sorted list starting from 0 to I minus 1. So when I equals 1, you only have one element because I minus 1 is 0, so you only have one element in the sorted list. So first, you pick I, the current element you want to compare, into current element. And this is a temporary storage. And then our k starting from I minus 1. And if that element is greater than k element, we continue to move k down. And we use that current k and the k plus 1. We move the k to the k plus 1 location. So it's a right shift. And because the k equals I location, we already stored it into the current element. So there's no problem. So we keep shifting until list of k is equal or less than the current element. Then we stop there. At that time, we do not go into the loop. So that k actually been over subtracted by 1. So we need to put that 1 back and then move the temporary storage to that location. So that is the location we would like to insert the current element. So here is an example. We do insertion sort on this list. And let's look at the execution result. So the array like here, we sort it into an ascending order like this. Thank you.